Good evening, friends. Welcome to Eason Academy. And we are into embedded system programming. As a part of it, today we are going to discuss about embedded systems. What is embedded system? Session 7. The previous section we discussed about what is embedded, what is the difference between embedded and VLSI, and what is controllers, and what is a complex system or not. Today we're going to discuss about the almost ultimate of embedded system. That is what today people use. That's called embedded Linux platform. Okay, that's a very important to know that. This will give you the good idea about the roadmap, how embedded started, how embedded has grown. This will give you the good idea about that. Understand? So better learn this, and this will be your final destiny of embedded systems. Okay, this will give you the good entry into the big companies and good pay package, everything. This is the one you're supposed to aim as an embedded engineer. So with that, let us get into the thing. So as we discussed, embedded start with very simple. Please understand, even though I discuss about all these things, you have to be strong on something. What is you have to be strong? As I said, electronics is, repeatedly I'm telling this, always never forget electronics. Electronics is an electrical signal and the electrical signal out. Now we put a small computer inside the electronics box. That computer had three things. One is microprocessor as CPU, and we have a ROM which contains your program, and we have a RAM, and this is your input, this is your output. So what we do here is this software here inside the ROM, which you call it as a firmware, which reads the code from the system and write it. So I read from the pin. I read from the pins and write to the pins. And I process. Who process? Your software. And initial days, we used assembly language. Nothing called assembly. Assembly and machine are same. Assembly and machine are same. That means that I say that move A, R0, R1. And that has equivalent one is 41. So this 41 is called machine language, and this is called assembly language. And the major problem with the assembly language is this is unique to the particular company, microprocessor company. For example, Intel, ARM, PIC, Atmel. Each company have their own assembly language. So if you move from Intel to ARM, you have to learn the assembly of ARM. If you move from ARM to PIC, you have to learn the assembly. PIC to Atmel, you have to learn. And that time only, they have taught, not many people, but our Dennis Ritchie. And of course, there were a lot of languages called language A, B, like that. And Dennis Ritchie has modified them and finally got a language called C. Dennis Ritchie created the C language only for his own purpose, to writing an operating system called Unix. It's a very efficient operating system which he wanted to build. So when he was working in a company called Bell Laboratories, Bell Labs. So please understand, C was not created for you or anybody. C was created by Dennis Ritchie for his own purpose. What is the advantage of C? If I write on C, I have a compilers which will work for Intel, ARM, PIC, Atmega, any processor. So your single code will work everybody. That's the reason they brought C. But unfortunately, initial days, if I write on assembly, If I have 10 instruction, if I write on C, it will become 20 instructions or 30 instructions. So what happened? People cannot afford to do, because if I have to read 10 instruction, it will become fast. If you do 30 instruction, it's slow. And those days in 1970s and 80s, the microprocessor running at very low frequency. That is clock speed. See, for example, let us think of it. If I have to drive from place X to place Y, if I walk, you will give me the shortest distance. Understand? If I have to go by cycle, you will give me slightly longer distance, but it will able to be a good road. But walking, you don't worry about the road, because it could be even a small lane. I can walk, but cycle may not go there. But if I'm going to use the car, you will give me the best route. Maybe a long route. You'll give me the best route, because I will go at high speed. That is what happened. The initial days, the processor was very, very slow. So I use assembly. Then processor is increased faster. Then they have moved to C. Now what happened? The processor has moved faster. Also, I had so many other controllers to do the job. Each one will do some job. People don't know how to manage that so many controllers. So, see, last time we discussed that we have a complex embedded system. That is nothing but I have a hardware which has so many facilities, and I have so many processors. Each processor will do one. There'll be microprocessor 1, microprocessor 2, microprocessor 3, microprocessor 4, and this will be controlling the SD card, and this will be controlling the DRAM memory. This will be controlling the USB. This will be controlling hard disk, SSD, whatever it is. So this will be controlling Ethernet. This will be controlling Wi-Fi. This will be controlling Bluetooth. So think of an embedded system today, which has all the facilities are there. That is called, this is actually a hardware, complex embedded system. But today, we are going to discuss one more thing. That is a trick. What happened was, when I had more, see, think of a small idea. You start a company. Start a company first. Let us assume that I start a company. In my company, I am the only guy. I will do all the activities. What are the activities? I will do accounting. I will do sales. I will be a technical person, do the technical work. I will do every activity. Right now, same thing now. You have only one microprocessor. You have some inputs. You have some outputs. You write a few small software, which will take the input, which will give the output. The task was, this embedded system task was very simple. Now, what you have done, you slowly added more devices, and you have controllers. Then what happened? You started controlling the controllers. And it's only few. You are doing it directly. You are the director. These are all employees. But suddenly what happened? You started adding more controllers. You are not able to This guy will say, sir, I completed the work. Give me a work. You have 1, 2, 3, 4, 5, 6, 7. The seventh guy said, I completed the work. Give me a work. The sixth guy said, I completed the work. Give me a work. So like everybody started saying that, give me work, I'm completing. You get confused. So what people did was, beautifully, they have defined a software called operating system. A small layer between your top application to the bottom hardware. There is a layer called operating system. This is exactly a management layer. What the operating system does is, whenever application gives some work, this guy will give it to the specific hardware. Understand? This is nothing but software once again. So I split the software into two. Now I become a director. I become a top level guy. I talk to the manager. Suppose I have 10, I have to do some 10 work. How do I do the 10 work? That's a trick. What this operating system will do is, he will take the 10 works one by one in a queue. And he will give it to first work to the microprocessor. Then he'll give the second work. Then he will give. This is called scheduling a task. Which you don't have to worry. As a director, I will give all the tasks to my manager. A manager will write down 1, 2, 3, 4, 5, and he will get the work done one by one. Think of it. See, I have told you so many times. You see everything without much confusion. How a company was built. First one guy, then you have more guy that you are handling directly. That is what you will do now. So what you will do is that in our embedded system programming, first what you will do, you will write a embedded C program to get the input and control the output. That is we call it as a passive. That is, what are the devices? Switch, LED, 7-segment, dot matrix, keypad. You will do it directly. You do not need anybody. But when I'm doing so many work, I'll start giving you a project like that. Then you will find out you cannot handle it. Then what will happen? You will start handling so many controllers. If you input controller, output controller, there'll be a controller for LCD. There is a controller called a timer. There is a controller called RTC. There is a controller for keypad. Like that, you will have a controllers. What the controller will do, it will reduce your work. They are employees. Now you start applying the employees. They will do the work. But you are controlling them directly. Then you add more controllers. When you add more controllers, that is now your system becoming big. Your company become big. When your company become big, so starting company, one guy, you are the only person. Then you are the one person manager, you are director, you are manager, everybody, and you control the employees. Now you are the manager, the director, and you appoint a manager, and the manager controls the devices. You understand? That is what this operating system. The first thing is operating system does is how you are giving the work. You may be giving so many work. When you have a manager, you say, manager, can you send the detail to the other guy? Manager, you give all the work to manager, but manager will not do it. Please understand, manager will not do the work. What the manager will do is, he will just manage. He will give the work to these people, the bottom employees. They are the controllers who will do the functions. Who will control it? The operating system. The first one is, what are the process? Second one is, everybody has been allotted, let's say you have a memory of 1 meg, for example. and you have so many tasks to do. I allocate memory for each one. That is called memory management. That like account manager, like a finance manager. Am I right? Like admin manager. Like that. I have a disk. I have a USB drive. I have a hard disk. You should store everything on the disk and retrieve it back. Those are called disk management. See, don't worry about this. It's all you will start writing after about 1 or 2 years. Once you start going the same way which I discuss, slowly you will get. I'm giving you the idea because where you are going to go. That's why I'm discussing today. This you are not going to do tomorrow, but you should know that how to go, and where you are going to reach. We are starting here. This is called roadmap. You may take 2 years or 3 years. That's enough. Then your path is fixed. This is the way, the ultimate requirement in the industry. This is the one will give you the top level companies. Whether you take Qualcomm, whether you take Intel, whether you take Apple or whatever company you want, you can get into this if you know that. Every company uses this. You know that you are. I'll discuss later. I'll discuss in a few minutes. Before that, we proceed. Now, same way, like a process. I do. See, let's say your mobile phone. You can talk and simultaneously you can watch the video. Like how you do that. Like that, you have a memory. That memory has to be allotted to multiple people. And there is a thing called, you have a disk. Am I right? That's how do you manage the disk. Then you will do networking. You may be having a wired network, wireless, Bluetooth, and so many things. How do you control all of them? That's called network management. So now what happened? We appoint small managers for every task. This case is called account manager. This case is called admin manager. This case is called finance manager. This case is called technical manager. Each one will control so many people. Okay, like say, the finance manager will control all there'll be a person called sales manager who will control the sales people. Understand now? Now what happened? This operating system has at bottom level one more guy, which has so many units controlling. This is called, they given a name. This is called kernel. This is a very critical. That's why they call it a kernel. Kernel means that you know the center. This is called. So please understand the difference between operating system and kernel. Both are not same. In your mobile phone, Linux is kernel. Android is OS. Please understand the difference between kernel and operating. Operating system is a manager, whereas the kernel is the one who actually does the work. This is a virtual software code. That's the work. The operating is someone who will be managing who to do and what to do. He is the one who will talk to your application. You are the director. You are the very top level. You are the user. You just write a small. You say that, let's say you want to write some file. You say like this simple. You say open. Temperature dot text. Then write. Okay, let's say this is called FD, file descriptor. Let's say write FD, comma, buffer. Let's say you define that CHAR buff 1000. Then you say buffer 100 bytes. So that means that you're opening a file and you are writing 1000 bytes. That's what you do. When you do the notepad, when you do notepad and type it, this is what's happening. You may be confusing why Balaji is explaining all the computer thing on my embedded system. Okay, I know that. These are all maybe the questions you have. But I have an answer now. I have an answer. I'll give you the answer now. In about another, before we end the session, you will have an answer for all these things. So this is what people have used in the computers. I mean, every computer was this. And every computer is having OS. For example, your desktop computer is having Windows. Windows is having two parts, which they don't tell you. One is called OS. That is called your Windows 98 and Windows 2000. Okay. And what do you have? Windows 7, Windows 10, Windows 8. All of them are called operating system. But they have a kernel. That's called NT kernel. Don't get confused between the kernel and OS. Windows is having two parts. But the beauty is kernel will not operate. Kernel will be there in only memory. Only when the OS tells it, it will do work. These are all be part of your system. It will be there on your memory when you're loaded. When you boot, this is called booting. When you are on the computer, it comes and do the thing. Why I have to explain to you this now? What happened was, suddenly, my embedded system having a small devices, only one input and output. This is where we started in 1980s. It's a very simple system. Then it moved to more controllers. More controllers. Then people have got every company had their own software, okay, to manage the controllers. They are called proprietary OS. Every company had the OS. That is what this. Very unfortunately, if you work on one company, you cannot go to other company. But there's a problem happened. What is the problem? Is the trick. This what they used in Windows, they were not able to put it onto the microcontrollers because they are slow. The Windows works very, very slow. But that time there's no other OS. Fortunately, what came was Linux. What is the advantage of Linux? Is the open source. What is open source is they've given you the entire source. Today, let's say you want to learn how the Linux work. You dedicate your life. You can go line by line, all the code you will understand. But Windows, they will not give you the C file. You will get all the C files in your Linux. You go to site called kernel.org. Sorry. You go to the site called kernel.org. You will get the entire Linux. What I'm talking about is kernel. I'm not talking about OS. Fine. I'm talking about kernel. You can see the code. But the only mistake happened was, not mistake, only bottleneck was, there's a problem. They have this OS are all secure. What is secure is this? There's a process is there in the memory. One process cannot access the other guy's memory. That is not possible. How could it possible? What happened? They have a system in between your microprocessor and the memory. They have something called MMU. Memory Management Unit. This is missing on microcontrollers. No microcontrollers those days, about 20 years back, 10 years back and all. Even 10 years back, they start coming. About 20 years back and all, did not have the MMU. Because there is no MMU. What the MMU does, the address given by you, what is this, your microprocessor, will be converted to different address. This is called, the address goes to memory. It's called physical address. The address given by your PC is called virtual address. I'll give you a small example. Yesterday, we have seen the C class. In the C class, we did a small code. You write a small code now. For example, you write a code called char x, printf, %d, and x. You get the address some 7456346. This address is called virtual address. That is the reason you force address here. I told you that if you write a program, character star x is equal to 5000. This you should not do it in the computer, because if you do here, that mapping will not be there. This virtual address 5000 to this address, mapping will not be there. That's why you are getting a segmentation fault. MMU is not programmed for this address. You may not know that, what address to be given. That's why you are not supposed to force the address when you write a program in your operating systems above, like a Windows or Linux or everywhere. This is not acceptable. But this address is allocated by the compiler, so it's fine. So this virtual to physical address is converted by MMU. This is must for your Linux. Also, there's one more problem in Linux. The other problem. These are not written for electronics. They are written for computing. So what happens if you give multiple tasks? Task 1, task 2, task 3, task 4. Let us say one you are browsing, one you are playing a MP3 song, one you are typing, one you are doing a PPT, whatever it is. When you do multiple activities, what this our OS does is, it makes it in a queue one by one. Task 1, task 2, task 3, task 4. That is given to the microprocessor. Microprocessor will do only one task at a time. When the one is doing that, if his time is over, the OS will stop and give it to time 2. Everybody will be given a time slice. When the time slice is over, he will stop and he will save everything. He will come back to the again. This we will discuss on later when we discuss a thorough on embedded Linux. Now I'm giving you the idea. What is this? This will give you some good insight, such a way that you will be able to read tomorrow what is embedded Linux. You will get an idea. So this process, suppose task 4 is there, only after 1, 2, 3 it will come to 4. But let's say you want to know that in your system, in your electronic system, if there is an input comes, if the output have to come within about a few microseconds, this does not work. That is why people are hesitant to use the Linux. Okay, this time is called real time. But these are called general purpose. Computing OS. Please understand the difference between real-time requirement and the general purpose. General purpose is the queue goes by one. It does not bother who is coming first, who is coming second, and what. He will not allow it to do the thing. But whereas this will affect, for example, think of a minute. You have a plane. You have a plane which is flying. Okay. You have a plane flying. There is a missile is attacking, coming. Now you have a sensor. You have a sensor. The sensor detected the missile. Then you have to fire a counter missile to nullify this, or you have to change the direction. If I do on this general purpose OS, gone. That does not work here, because the timing is not assured here. Because of that, the missile will come and hit your plane. That's the reason people have created a OS called real-time OS. The real-time OS has two advantages. It does not worry about your MMU. So this does not, this does what? This is RTOS, they call RTOS. RTOS work without MMU, whereas your Linux need MMU. Please understand, MMU is must for Linux, whereas RTOS no need of MMU. Second, in Linux, you have a conversion of virtual to physical. In RTOS, there's nothing like that. But the problem is, RTOS cannot be used for your general purpose applications. Understand? Your general purpose application, RTOS cannot be used because it has so many loopholes, no MMU. So NVIDIA can write any memory and everything. But this is good for embedded. But very unfortunately, there is not many standard RTOSs. But what happened before that? Before RTOS pickup, the major advantage was the CPU speed has increased. CPU speed has increased. Go to gigahertz, 1 gigahertz and all. From the megahertz, they gone to gigahertz 1,000 times. Because of that, and even the processors with MMU, microcontroller with MMU in the market. So what happened? Your Linux itself is doing better, almost like RTOS. Even though this is having a queue, but because of the microprocessor is fast. The microprocessor is fast. Your Linux will be able to run faster. So this is the path we have done it. Understand the path. The path was, embedded path was very simple. First, we took input, a microcontroller. We took input, output. That is, you write a program like this. Int main. You write input and X. And you will say Y is equal to X something. Then you'll say output Y. See that? Like a scanf and printf. This is what's so simple. Later, you had a microcontroller which is having a microprocessor and a lot of controllers. One for timer, one for LCD, everything. Then you start writing a program print hello on LCD and delay 1000 milliseconds or 1000 seconds. That this game will take care of that. So you do not have to worry about how to print the hello. That who will take care of that? The LCD controller. And you will do the other one called get the RT real time. That means that this game will operate with the battery. There'll be a battery backup. Once you set the time, this clock will be running. Let's say, for example, you wanted to measure a temperature every minute and store it on the disk. Okay, you will write a thing called, see here. You will say that timer in it. The timer will give you an interrupt every 1 second. That's called ISR. The timer will give an interrupt on every 1 minute. Every minute you will go that read temperature. Then you will say write on SD card. That's it. You will do only 2 functions. You are going to do that. I'm not going to, these exercises will be done by you as a part of this embedded system programming. You will do all these things. Okay. This even though I'm telling you the idea top level, you will do all this, then you will understand it. That's a way, that's a time only you will start thinking about projects. How people do projects you will understand. You have to do a project by yourself and write that on the resume. Then only you have a value on the interviews. Not just doing the LED control. You have to do a project. Then what happened? People had a OS to control them, more controllers. This is called proprietary OS. They have their own, no, they will not tell you what it does. But very unfortunately, if you buy them, they have to depend on the company only. Then came was ATAS. It's a very general purpose. Understand? But it's a real time. But can be used to only embedded. But that is a time people have come out with the how to use the very general purpose OS Linux. Why I have to use the general purpose OS? I will come to you now. I have explained the roadmap. This is what roadmap you're going to do that. You will do that. If anybody is interested, tell me. I will make you to write a operating system. You will write your own OS. It's all very simple process. Nothing difficult. The whole process is very easy. Nothing. Then the only problem is all these things, as I mentioned, you need to be good at C programming. This roadmap is very simple. I've guided a lot of people who are doing too good. Okay. I've guided a lot of people, they were doing too good now. The career path. But you will never realize now. You will realize only after 3-4 years. Whatever fundamentals I'm giving now, you will realize the thing when you are in the company, not now. All these things your brain will take. I'll bet these things, what I'm telling you today, will be very, very useful tomorrow. You'll be very surprised. You understand the full path, which you don't get it anywhere. How it's a grown thing. But these things you will do it as a part of our basic embedded system programming. And at the end of it, if you like, you can start doing the OS also. That's you can do that. Okay, these things I'm going to have other programs called intermediate and all. Don't get confused now. Right now, try to master this. This starts from next week. Monday onwards, we are starting the first program. Okay, then you will know that how to start writing the program. Then how to apply the C programming. Now, I'll tell you some important thing here. Why people started using the general purpose OS was, in every computer, suddenly a USB came. SD card came. Networking came. And Bluetooth came. Zigbee. So many things on SSD hard disk. So what happened? Your computers started supporting everything. And the computer is used by many people. Okay. There was few standard OSs, Linux, Windows, and OS X from Apple. There were 3 famous. But this only for generally in PCs. So they've not ruled out. And OS X is only for Apple computers. That's it. The only left out was Linux. What happened on Linux was, Linux given a beauty. They have a method to configure the OS. Understand? Configure the kernel. That means that you can download the kernel from kernel.org. You can download the kernel from the kernel.org. Yeah, Zigbee is another networking. That is actually low power wireless. For example, like a Bluetooth Zigbee. The thing is that, let's say you have in your house, there'll be a small sprinklers. There'll be a sprinklers. There'll be a battery. And there'll be a small microcontroller with Zigbee. This Zigbee will be sleeping always. This microcontroller will be always sleeping. They don't take the battery from that. It will work for years together. Of course, now and then it will sense the temperature. It will wake up and sense the temperature and go to sleep. The moment it finds the temperature, rise, then The ZigBee will give a signal to the other people, the next controller, the thing, and the sprinkler will give the water. So that ZigBee is a very low power network, like exactly like a Bluetooth. It's a wireless network. It is for distributed networking. So the thing here is like this. Let's say I have a microcontroller. You have a microcontroller. You have a microcontroller. You connected the hard disk, SD card. You connected the Ethernet. And you connected the SSD, for example. All the three can download the kernel. You will enable only SD card. You will remove all the other things. You will enable only this. These are all very good today. Every company wanted you for this. Now you will remove here only everything except Ethernet. Here will your SSD. So there is a well-proven, well-tested kernel is available to you, which is tested by thousands of people. Every laptop and every computer is working. So because of that, and this is also open source, free, open source and free. You need not spend a single penny for development. So you have to recruit a person, do the work, and that companies are, and this all standard, supporting everything. That's the reason people started using this Linux. You can make a Linux as small as possible. Remove all the unwanted things. Once you start practicing controllers, I'll tell you when to get into Linux. Slowly start in your laptops. Slowly move from Windows to Linux. Let's say you start understanding what is Linux, how to configure a laptop with Linux. You can have a laptop with Windows and Linux, both. Start using Linux slowly. Okay. And there are two modes for that. In Windows, you have only GUI. In Linux, you have two modes, graphic user mode and CLI, command mode. Command mode is preferred. If you want to do, let's say you have to be very clear. You are going to establish your path in embedded long term. You decided that I am going to be in the field, embedded only, whatever happens. Then start moving to Linux. Understand now? It's all based on how do you plan your future. Now I'm going to give you one more thing. It's a very important, which is what everybody's wish. Most of the embedded people love to do that, and every company wanted that. Now I have told you there is an operating system, application. And there is a operating system. In Linux, we have GNU operating system. Kernel is Linux. GNU OS, Linux kernel. Your Android phone, Android is OS. And Linux is kernel. Please understand, all your Android phones or Linux operating system is there. Please understand. This is your kernel. And this is your hardware. The thing is that between the kernel and the hardware, there is a piece of software is there. This is what exactly you are wanted. This is what you are. This also can be handled by computer system people, but this is what you are needed. This software is the one which is talking to hardware, which is talking to kernel, which takes an input from kernel and it will write it to the hardware. You know what is this software called? They are called device drivers. These are called device drivers. Understand? This device driver is the one which is exactly like a firmware. The huge demand is there, and you exactly fit in there. From the hardware, you will move to this. You will learn everything, but you will move here. The moment you understand the firmware, the moment you understand how to do the programming on controllers, the moment you understand the ATAs, then you are fit into the Linux device drivers. This is exactly like a firmware, where there's a software which will control the registers of controllers. So exactly whatever you do controller programming, going to be here. So this is the path most of the people getting. And if you understand whatever I'm discussing now, pointers, and how to access the control registers, that's what I'm giving a foundation. All my foundations are exactly for this. Of course, once you do this, you can write application dot. They're very easy. These are all very easy, man. The people, those who have done this, right now what you are doing is, you are doing the hardware and you directly write the firmware and controlling the hardware. Understand? But what I am telling you next is, you will go with the device driver to the thing. I'll share one of the thing before I go further, which I mentioned to you sometime back also in the class. Let me take the thing and do that 1 minute, which I've already written in article in Quora. So 1 minute. It will take a minute for you, because I have to show you the image. This is what the formula which I have created. Sorry. I think I hope it's visible to you. You see here, see the path. So this is the path. See here, programming in C. That's what you're doing right now. So next week, you're going to see the programming on the embedded systems. Then programming complex applications. Then programming embedded application, advanced embedded applications. Then what? File handling, networking, and debugging. Good, that GNU debugging, everything coming here. But everywhere programming C will be there. See, embedded networking and ATAs. Then finally, embedded Linux, developing device drivers and Linux internals. See that. This is a 7-step formula. Understand now. This 7-step formula, if you go, okay. But after the first 2 steps, you will get a good job. These 2 steps are sufficient to get a job. Don't get confused for the 7th step. But once you get into the job, you have to parallelly work on this to get to the top level. Every day working, like every day 1 hour. Spend the time. Within about 1 or 2 years, you will become master of this. But you better master the first 2 levels to get into the company. That's very important. Without mastering first 2 level, don't go to the 3rd level. You understand now? Is it clear? If you have any doubt, you can ask me now. What is the roadmap for the embedded engineers? Why I've explained today is that the path I've explained. Okay, after the next session, I'll explain some more important thing about this step also. Before you go to the step, there is one more step came in now, which I've written generally, but fortunately it came now itself. It will be a good advantage for you. But the whole thing is very simple. Please understand. Nothing as complex as you studied up to 12th. Even this syllabus is, these things are all much easier than what you have studied on the +2. They are much easier than +2 level. The only thing is some mind block, which I have to use the word repeatedly, mental block. You think it's complex, which I cannot do one thing. But the thing is that Why you think complex? Do you know do you know the reason why you think this is a complex? Anybody can give me an idea now. Why you are thinking the whole thing is complex? Anybody? Anybody, please give me a thought. Why you think the whole embedded looks to be a complex for you? Please. I want answer from at least a few people. Why you think these things looks to be a complex for you? Why everybody is telling this field is even though this field is very easy field. Even I trained 7th standard, 8th standard students. Why you people think it's due to unfamiliarity, not consistent work? No, not like that. These are all not the reason. There's one more very important reason is there. There's one more very important reason is there. No fear. It's not about fear. Fear is one reason which they told you. Not proper direct. No, it's not like that. Nothing. It's one small thing. You people are not understanding yet. That's surprising. I've told so many times, but you are not able to understand that. Our whole education system makes you the memory card. They treat you as a SD card. They make you to memorize vomit. That was that required. Correct. That is perfect. Somebody has said, I'm applying the class knowledge in practical. The mistake was what you are doing is you are memorizing a lot, but you practice a very little. Now, what I'm telling is don't do this. Don't do this. Learn a very little. I'm going against your system. Learn little, but practice a lot. This is what today. You are afraid of practicing. You are afraid of, you don't accept failures. You know that because you know the education system. If I do this practice, I may fail. But the beauty is while practicing, failure is acceptable. Is acceptable. If you worry about failure, then you will never practice. That is what your problem. Your problem is your program should work. Okay, your problem is when the moment you swimming, you should swimming. Somebody will tell me that or laugh at me. Don't worry about anything. In this case, you are the only guy. You and computer, you and PC. You write a program and that guy is going to compile. Nobody to laugh at you. Don't worry about that. And worst case, you're going to share it with me. I'm not going to laugh at you. I know the people. I'm making people. I will never say that you are wrong. I will make you to correct only. So please keep practicing. No, why I'm telling you this very important things to you repeatedly is a big treasure. It's a huge money is there in the field. I don't know who told you these things are difficult and not to practice, or I don't know. I'm literally worried. Such a huge money is there, and there's no competition for you, electronic students. There is no competition here. You can do the very smooth sailing, and I don't know why you put yourself. You know one thing. There'll be a story they will tell you. You know what is the story? When the elephant was too small. The elephant was born cub. That person who maintains the elephant will tie his legs with a small thread. You know one thing, when it becomes big also, the elephant can throw away the thread in 1 second, but it'll always afraid to do that because of the mindset. You have been doing almost same thing. Somewhere you got fed up. Somewhere you got lost your thing that I will not learn programming. That mindset is there with you. That has to be removed. Start doing. You become wonderful. Then next session, I'll give you some more insight about that. Yeah, I'm an electrical engineering student. I am electrical engineering. I did BE EEE. Even the years when the electronics was not there, I've seen my computer only during my MTech. I never seen a computer during my thing. I learned programming in by age of 37. I learned C programming at age of 37. Till that time, I was a hardware engineer. Yeah, BTech, E is a very good field. In the world, only in India we have ECE. Only in India we have a CSE. Only in India we have IT. These are all called EEE, ECE, CSE, IT. Everywhere in worldwide, they call BS EEE. That's all. All over the world, there's a BSEE only. Electrical engineering only. All these things are part of electrical engineering. But in India, we have some field called electrical engineering, but we don't specialize any one of them. EE people do not specialize electrical. ECE people do not specialize electronics or communication. And CSE people never specialize on computers. And IT people never specialize on, you never understand what are these terms. Ultimately, everybody go to the IT services job. Understand? Don't worry. E is a very good job, very good field. And actually, full electronics is all about electrical input, electrical output. Don't worry about that. You can do wonders. So, okay, then let me, if you have any doubt, you can ask me. Otherwise, I given you a good idea about what is embedded Linux. When I start giving other individual lectures, I will record and give it to you. So you can learn it when you have a time comes. Okay.